Hello friends, welcome to my channel. In this channel I make videos on mathematics for class 6 to 12 and coding tutorials on in C, C++, Java, Python and more as and when I will explore with time. If you find my videos useful, then please support me by subscribing to my channel, hitting the like button and pressing the bell icon. In this coding video I will briefly address on Python objects, their types and values. So let's get started. Okay friends, I've listed down all the points that I will discuss regarding objects, types and values. On the right hand side, you can see all the 7 points that I will discuss, and I will try to explain them in the Python interactive shell on the left hand side. So in Python, all data are represented by an object which has an identity or type and a value. So data means it can be a numeric, it can be a string, lists, sets, dictionaries or even functions. There is a built-in function in Python known as id. If you pass an object as a parameter to id, it will return the identity of the object. So identity is an integer value of which remains the same throughout the lifetime of an object. It does not change. Similarly, we can get the type of the object with the built-in function type. If you give an object as parameter to the type, it will return the type. This return type is also an object itself. Now to compare if two objects refer to the same object or not, we have the is operator. If we do object 1 is object 2, if it returns true, that will mean that object 1 and object 2 refers to the same object, and if it's false, then they refer to different objects. Let's try to understand these things, this point in code. Let's say I'm assigning value, giving an integer variable, let's say x equals to 10. So if you do x id x, it will return the identity of the object x. Now this x is an object whose value is 10, id is which is printed, and if you type x, it will show that the type of the object x is int. Similarly, if you do a list and if you do a list a string hello world, we can check the id of L, which is some integer, and also an id of S, which also gives a integer, a unique integer, and we can also check the type as well, type S. So L is a list and S is a string. So first point is clear. Now point number 2 says that objects whose value can be changed are said to be mutable. In Python, we know the mutable data types are lists, sets, dictionaries, and it could also be a user defined class. By mutable means that the value of the object can be changed. So this is pretty easy to understand and need not show any example. Let's see also point 3, objects whose value cannot be changed are said to be immutable, like numbers, strings, bytes, range, tuples, etc. Numbers and strings are constants, also bytes. In tuples, you cannot change our data items because it's an immutable data type. Now, number 4, this is very important to understand. Operations that compute new immutable values may actually return a reference to any existing object of same type and value. Let's understand this. How to clear this? I think Control L. Yes. Let's say x equals to 10. So now we have an object which is being x is referencing to an object whose type is int and value 10. What if I do, and we see id of x equals to 10, okay, is some integer. Now what if I do f y equals to 10? Do you think a new object will be created? It will not. If we print the id of y, it will be same as the id of x. We can even check that by x is y. It is true. Why is it so? Because while when we did y equals to 10, the Python interpreter saw that an object with value 10 of type int already exists. So the object x was assigned to y. That is the reason they both have the same, they refer to the same object. Now if I do, let's say x equals 10.0, I am assigning a floating point value to x. Now the data type has changed. Now it will not be the same case as before. Now x will have a new object. Just check it. id of x has changed. We can check that x is y. No, false. So when an immutable values are being computed, it will first check that if the value already exists in some previous object or not with the same type. If it does, then it will just return that reference of that object to the assigned variable. It is similarly the same, it is true also for strings. Let's say s1 equals s1 equals abc, s2 equals abc, s1 is s2. It is true, but it will not be the case if we use tuples, even though tuples are also immutable data types. Let's check t1 equals to 1, 3, t2 equals 1, 2, 3. We would expect that since the tuple 1, 2, 3 already exist in t1, now t2 should also refer to t1, but it is not the case, because Python says that operations that compute new immutable values may or may not. It actually depends on the underlying implementation of the Python interpreter. So if we do t1 is t2, no, false. So what is point number 5? Operations that compute new mutable values always create a new object. So whenever a new mutable value is being computed as an expression or being assigned to a variable, then always a new object is created. Let's see, L1 an empty list, L2 an empty list, and L1 is L2, false. L3 is empty, L2 is L3, false. So for mutable data type, it will always create a new object. So mutable data type like list, sets, dictionaries, and so on. Now point number 6, objects having references to other objects are known as containers. So we know that the container objects in Python are those kind of or special kind of objects which has references to other objects. Like the built-in containers are list, set, tuple, dictionary, and there are more. So let's take an example. Lists equals, if I do let's say number odds equals to 1 comma 3 5 7 events equals to 4. I'm just taking a very simple example. And numbers, if I create a numbers from the odds and evens, how will I do it? We can do this, like we can do this. Okay, so numbers, no, I'm sorry, I wanted to numbers. I want to create a list numbers which will have reference to the list odds and to the list evens. So let's say this, and numbers append odds, this events. So what is numbers now? Okay, now I just wanted to check that when we create the numbers list has references to the odds list and the events list. We can check that out with the id function. Id odds equals to the first element, data element of numbers is the odds. So numbers 0, it's false. Why? Come on, why? Oh, it should be id. True, and 1 events. True. Okay, fine. So these are, similarly we can have, instead of lists we can have tuples and sets and dictionary. Now point number 7. A container object is said to be immutable when the collections of identity of all reference objects is unchangeable, even if any reference object value is changed. Now this is a very confusing idea, concept, which need to be understood very well. We say that a tuple, immutable data types in immutable containers like tuples and what else? Tuples, bytes, they are all immutable. By that, it actually means that we cannot add data items to it, we cannot remove data items to it, or we cannot assign a new data item at a specific position. That's exactly what it means when we say that a tuple, any immutable container is immutable, like tuple or what else, range, bytes, etc. So now let's consider a tuple. Let's try to understand this thing. Let's say a tuple is 1, 2, 3. We know that we cannot assign new values to any index position to this tuple. We also cannot add elements to it. We also cannot remove any elements to it. So basically it means that the collection of the identities of all the objects that it contains will be same. Even if the tuple contains a mutable object and that object's value is changed, still the tuple is said to be immutable, because the value of the object that it contains, if it's changed, that doesn't change the identity of that object. So a container object is said to be immutable when the collections of identity of all reference objects is unchangeable, even if any reference object value is changed. But in case of a mutable container, the container object is said to be mutable when we can add elements to it, we can remove elements to it, we can also assign a new object at a specific position. So point number 7 might seem to contradict with points number 2 and 3, but the basic concept is that an immutable container object is considered to be immutable because the collection of IDs of all the objects that it contains as data items, that collection of IDs will always be the same. But it is not the case for mutable containers like lists, dictionaries, or sets. We can change, we can add data items to it, we can remove data items to it, which effectively is changing the collection of IDs of all the objects that the container refers to. I hope this was useful, and I'm not sure how I was able to explain it through examples. Let's see if I need to explain anything in a better way with examples or not. Yeah, I think this is all I have to say, and yeah, that was all for this video. Until the next video, have a great day and bye.